Hello everyone, welcome to this video. Moving on to the next slide, that is methods for analyzing a truss. So there are two methods for analyzing a truss. First one, analysis of a truss by using method of joints. Second, analysis of truss by using method of sections. So let us see the first one, that is method of joints. Now over here, as the truss is in equilibrium, so if we isolate the different parts of the truss, that is if we isolate the members, horizontal, vertical or inclined member, or the joints of a truss, so these joints should also be in equilibrium. That is the necessary requirement for the truss to be in equilibrium. So this method of joints works on this principle that if the truss is in equilibrium, then its joints should also be in equilibrium. So for this method, let us see what are the different steps. There are 8 steps. The first one is to check the stability of the truss. As we have seen, n is equal to 2j minus 3, where n is nothing but the number of the members in a truss. We can also write m in place of n. In case of a cantilever truss, we can check the stability by using n is equal to 2j minus 4. The second step, we need to draw the FBD of the entire truss, mark the reaction components, and then we need to apply conditions of equilibrium to find out the magnitude of the support reactions. Then step number 3, we need to select a joint in such a way that not more than 2 forces are acting on the joint. Okay, so this is the step number 3. We need to isolate all the joints one by one, and we need to start with a joint in such a way that that joint carries not more than 2 unknown member forces. So we can apply summation fx and summation fy to find out the unknown member forces. Remember, while analyzing the truss, we need to find out the support reactions as well as the member forces. If there are 10 members, so we need to find out the magnitudes of the forces in all of these 10 members. Let us see what is the next step. Step number 4, we need to draw FBD of selected joint by assuming forces in members as acting away from the joint. That is, we are assuming these members are carrying tensile force. We need to draw the free body diagram of all the joints in such a way that we represent or we draw the member forces acting away from the joint. Next step, the forces at a joint are concurrent and each joint is in equilibrium, so we can apply conditions of equilibrium, that is summation fx equal to 0 and summation fy equal to 0. As we have discussed it earlier on, that only 3 conditions are applicable to the truss, but once we are analyzing a joint, we have only 2 conditions, that is summation fx and summation fy. Next, what we need to do, next step, find out some forces by observation or by inspection. As we have seen in the previous slide, 0 force members. If there is a similar case, depending upon the arrangement of the members, we need to identify 0 force members, or we need to identify the member forces by observation or by inspection. Next step, repeat the procedure by selecting different joints and find out the forces in all the members of the truss. Lastly, we need to tabulate the results in a force table using positive as tension and negative as compression, and we need to mention the nature of the forces of a truss. So these are the 8 steps that we need to follow while analyzing the truss by using method of joints. By method of joints, in exam it may be asked for 6 or 7 marks depending upon the number of members in a truss. So let us see one example on method of joints. So this is the example. Use method of joints and determine the forces in each member of the truss. Now over here I have directly shown the solution. You can see there is a truss which has members A, C, D, B, E, and external loads are applied at point C, D, and E. At point A, we have a hinge support. That is why two components of reactions are shown, AX, AY. And at point B, we have a roller support. That is why we have shown one single reaction acting in upward direction. Now this figure is the free body diagram, that is a part of solution. I have directly drawn the free body diagram. Now over here you can see we have isolated the truss from its surrounding and we have shown the reaction components instead of the supports. So the first step is to check the stability. So let us count the number of members. How many members are there? AC, AE, CE, CD, DE, EB and DB. So total 7 members are there. Number of joints: joint A, joint C, joint D, joint B and joint E. So 1, 2, 3, 4, 5 joints are there. Now let us substitute the values of M and J in our equation, that is M is equal to 2J minus 3. So we get that the truss is a perfect truss and it can be analyzed by using the three conditions of equilibrium. So our next step is to find out the support reactions AX, AY by applying conditions of equilibrium to the entire truss. Now this is an important step. We are applying conditions of equilibrium to the entire truss. Okay, and by applying summation of moment at point A, we got the value of RB as 40.5 kilonewton and it's acting in the upward direction. So our assumption is correct that RB is acting in the upward direction. Now by applying summation Fy, we got the value of AY, that is 3 kilonewton, which is also acting in the upward direction. Since there is no external horizontal force acting on this truss, that is why value of AX will be equal to 0 as we apply summation Fx equation. Now from this third step, our method of joints will start. The first two steps are general steps that we need to follow in almost all the type of analysis of a truss examples. Over here we can isolate joint A or we can isolate joint B. What is the condition for isolating the joint? The joint should not have more than two unknown member forces. As you can see in the figure below, at joint A we have AX, AY, the values of which we have already calculated. Apart from that, we have two unknown member forces, FAC, FAE. Now as per our assumption, we have shown the direction of FAC acting away from the joint. As we are analyzing joint A, so from A we have shown FAC to act in the direction away from the joint. Similarly for FAE. Now we'll apply both the conditions of equilibrium, summation Fx and summation Fy, for finding out the unknown member forces FAC and AE. By applying Fy, we got the value of AC as minus 41.57 kilonewton. And by applying Fx, we got the value of FAE as 20.785 kilonewton. Now what does this mean? FAC, we got the value as minus 41.57 kilonewton. That means we have assumed FAC to act in a direction away from the joint, that is it carries a tensile force, but after analyzing we got the value as negative. This negative value implies that our assumption, that is FAC acting away from the joint, is incorrect. Okay, please don't get confused with the negative sign. It is just a representation that our assumption is incorrect. We need to our assumption is incorrect. FAC is acting towards joint A. That means it is carrying a compressive force. Whereas FAE, we got a value positive 20.785 kilonewton. That means our assumption is correct. It is acting away from the joint. Now focus on the equation of summation fx. See what we have written. FAE plus FAC cos 60. Now, though we got the value of FAC negative in the first step itself, despite of that, we should not change the direction of the forces in the FBD. And in the same way, we need to use the same components that we have shown in the FBD. Now from the FBD you can see FAC is acting away from the joint, so its x component and y component will be positive, that is FAC cos 60 and FAC sin 60. So while calculating the equation ahead, we should not change the direction of FAC. We need to substitute its value, whatever value we got positive, so we will substitute the positive value. If we get negative value, then we will substitute the negative value. So in this way we need to proceed. Let us isolate the other joint. Now we have an option to isolate joint C or joint B. Second, we'll consider the joint C. Now you will see that at joint C there are three member forces FCA. Now see the naming is changing. When once we were solving the support A, we called the member force as FAC. Now when once we are solving the joint C, we are calling the same force in the member as CA, whereas it carries the same magnitude as we have calculated in the previous step, but with a negative sign. As this is our assumption that we need to assume the direction of the force is acting always away from the joint. If we get a positive value, then it represents that our assumption is correct and the member is carrying a tensile force. If we get a negative value, which indicates that our assumption is incorrect, the member carries a compressive force. So in this way we isolated joint C, we applied summation Fy equation and summation Fx equation to get the unknown member forces. Similarly, we isolated joint D to get the unknown member forces FDE, FBD. Next, now we are left with only one member force, that is EB. So for that we again need to isolate the joint B and apply conditions of equilibrium to get the value of the force BE. Now over here you can see we have firstly applied summation Fx, we have substituted the value of FBD that we have got as negative, and then we have calculated the value of FBE, that is 23.383 kilonewton. Now there is a check that has been performed just to understand that the answer that we are getting is correct or incorrect. So over here you can see summation Fy is equal to minus 46.766 sin 60 plus 40.5. So we got the value of summation Fy equal to 0. That means whatever value we have calculated of FBE is correct or FBD is also correct. It is not always required to perform such a check. If you have any doubt while analyzing the truss or the joint, you can carry out such a check, but it is not expected in the solution. So moving on to the last step, that is the force table. Now we need to tabulate the values of all the member forces that we have calculated with their nature. So we got the value of AC as negative. So 41.57 is the value, which implies that it is a member which is carrying compressive force. So we have indicated the nature of the force by writing capital C, which stands for compression. And if we write capital T for any of the member forces, it indicates that the member is carrying a tensile force. Okay, so this is one example on method of joints, how to use method of